Hello, good afternoon. This is Akash. I'm making this video to kind of give an update on something I've been working on. Uh, I would not have made this video to be honest, but since I've sunk in a good deal of time into this particular project, yeah, I'm kind of excited. So sure, a video, why not? Uh, on top of that, I think like I've been working on this for the past 1 month, and it was more of a, I would say, refactored rewrite with a more clearly thought out API surface. Uh, but again, I forgot to mention. So I've been working on this rendering engine. Last time I tried writing it was all right, but I felt that the API was not at all uh, like clear and extensible. So I could see that eventually, um, I mean, it would not go anywhere, right? So this is the rewrite basically. I will shortly go through, I would say, a brief overview of the API and how I've approached this particular problem. Of course, I mean, if you're a veteran watching this video, I mean, feel free to give me suggestions because I'm learning and I by no means am an expert on this, so I have a lot to learn. Let me quickly give you a demo of this thing. I have named it Dynalar, and this is the second iteration, so V2. I'll straight away jump to the part that I finished yesterday, which is rendering a model. In this case, this is a GLTF2 model. I have tried it with OBJ models as well, works fine. This particular model, I have kind of got this from the Kronos group GLTF2 demo repository. Uh, I mean, honestly, this model is way more detailed. I mean, I can quickly show you how this looks with 3JS. I think it's this one. I go here. As you can see, this has a lot going on in terms of lighting and the detailing, and this is also, by the way, it has like a bit of translucency going on here, which I am not sure how to implement because currently I have face culling, so that pretty much removes everything uh, that is not visible to the user, i.e., any part inside the helmet would just vanish if viewed from the front. Also, I think there is a lot more going on in terms of simply the textures and how they're being rendered. I do have to look into it, as in how they are rendering it. Um, yeah. In my implementation, currently all I have is specular map and diffuse map. Um, and I think normal map should be easy to integrate, which I haven't done yet. But that, I mean, normal map will increase a lot of uh, details that one can see on the model. So let's see what all things I have managed to include. Of course, panning and zooming, scaling, as in, sorry, panning and uh, I don't know what you would call it, but you get the idea. You can move around, right? Uh, there is a FPS graph and an FPS controller as well. So I can actually increase the FPS because my computer pretty much supports more frames here, so why not? But I thought of capping it to a lower value. Uh, yeah. So, I mean, the way I had implemented it, it should not, like, it seems like every time I increase the FPS, the rotation speed increases. That should not be the case. I mean, my implementation kind of tries to keep it steady. by using the delta time calculation that you do, basically. So the update function is called accordingly based on how many frames it's rendering. So there's that. And right. So other than that, of course, you can go ahead and play around with the models. There are more properties that I need to support here, but there is a bug with IMGUI, at least from what I can tell. Uh, Only the first combo box selection works, and the second one is just stuck on the first mesh. I don't know why that happens. So, for example, if I select anything else, it just won't work. I'll figure it out. There's something going on. I was planning on displaying all the texture maps that are being used here. I haven't finished that yet because I was fiddling around with this to figure out what's causing this issue, so I did not bother like investing time on that. So yeah, you can switch to wire mesh. You can check normals. The normal display, or rather, like this debug mode using normals. I think I can improve it a bit more. But yeah. What else? Yeah, I mean, you can directly change the properties from here if you want. I would not do that because the animation looks nice, and I would not want to. I mean, the scene looks nice, so if I just randomly move this around, I think it'll look ugly, so I won't do that. And yeah, I mean, you can individually go to different items, fiddle around, play with their properties, etc. For example, we can change maybe the floor to this color. Why not? We can change the material properties basically. So the material properties currently support a diffuse color, a specular color, um, and if you provide meshes, they will, I mean, the material will basically use the, sorry, if you provide a texture, it will use the texture instead of these solid colors. I was thinking of using these colors to tint the textures, if you kind of get what I'm saying. But I thought maybe, I mean, that is something I can add later. Because yesterday when I was using Blender, I saw that in their PBR material they have something like this. So I guess I can try that out. Interestingly, there is no common consensus as to how to kind of tackle these things, which is kind of weird. But anyway, next up, cameras. Of course, I support both perspective and orthographic projection. So I have one. I mean, you can switch between the active cameras. So I currently have two cameras. First one is the one that I'm using currently. But I believe I did not check the position of the second camera, but I think I placed it. Oh yeah. So this is basically an orthographic projection, as you can tell. And I think you can change the position of this camera to get a different view. But yeah, I was thinking of using this as a top-down camera for like a mini map kind of a thing. So I was thinking of using the texture from or writing the output of this on a texture and using it like a mini map. But yeah. Anyhow, so basically you can switch between different cameras. So whichever you select becomes your active camera, and you can see the values of your pitch and position of your camera here. This needs to be read only because currently the way I've implemented it, I wanted to optimize it a bit. So unless you are changing things, the projection matrix is not recalculated to save resources. But when I added these properties here, I was hoping that this will be read-only, but for some reason IMGUI does not support that, at least from what I could tell. So the problem is, currently, even if you change things here, the object has no way of knowing that things have changed. So yeah, so this does not work the way it should. Yeah, but that's okay. In lighting, I support three types of light: the ambient light, the point light, and the spotlight. All three of them are being used in this scene, as you could tell. So ambient light is basically ambient light, like illuminates everything in scene. And you can change whatever color you want it to be. We'll just keep it on white. Point light is point light. And again, like, it has been placed in the scene here, so it's right here. We can like move it around a bit to get different light effects, and play around with specular intensity to kind of get different effects of reflection. Diffused is basically how it acts upon the diffused component of different materials. And again, like, you can change the color of it. Spotlight is what we have here, this thing. Yeah, so we can move it up a bit. This is more like a torch, like a flashlight. And you can also change the cutoff angle. Yeah, I was thinking of renaming cutoff angle to inner cutoff angle. Yeah, I'll probably do that. That makes it a bit more meaningful in terms of terminology. Yeah. And what else? You have input control. So basically, you can change how your mouse works and how sensitive it is to XY movements. Movement sensitivity is how fast and slow you are in terms of moving forward and backward with the keyboard. Oh yes, you can move with the keyboard, by the way, I forgot to tell. And to interact with the mouse, you hold Alt and you left click to do this look, look at whatever you want. You hold the middle mouse button with Alt to do this panning thing, and you use the right click to zoom in and zoom out, holding down Alt basically. And yeah, and it's pretty cool to see how nice this model looks actually. Yeah. Okay. So we can. Oh, and yes, these properties and everything here, as you can see, is completely dynamic. I will just go through the code to kind of explain what I mean by dynamic. And you can go back to this scene viewer, or rather scene selector, and you can select whichever scene you want, and that particular scene will be rendered for you. Yes. Right. So, yeah. So the API design, like, quite briefly, the whole project is split into an engine folder and a scene folder. The engine is made up of app, core, and window. Window is basically your GUI stuff, and the window manager. The window manager is the object that creates the window context and kind of gives you necessary, I would say, exposes necessary APIs for controlling the scene with your input devices. Yeah. And GUI is basically IMGUI stuff, right? App, on the other hand, is more like widgets and more high-level graphics objects that you can readily use. Other than that, it has something called a base scene object. A base scene class. And this kind of plays a major role in how the scenes are basically populated, or rather the controls are being populated automatically. I'll show how it works in a second. And core has all the, I would say, OpenGL specific stuff. So uh, vertex buffer object, vertex layout object, um, so on and so forth. Uh, the renderer here is what we use to kind of make the draw calls. So renderer also calls in the necessary, or rather enables the necessary features that we want to use um, from OpenGL. Um, hmm. The entry point of the application is, I mean, it is main.cpp, but then again, like the actual application starts in app.cpp. And so in app.cpp, what you can do is the app itself is supposed to kind of, just a second, let me show you. So the way it works is you create an app object and you use the app object to register different scenes. And this is how the home screen kind of gets populated, by the way. So this is how the application knows what all scenes you have, and each scene uh, is basically a class inherited from base scene, and then you can like implement your scene however you want, keeping in mind what base scene offers you. Okay. So the base scene itself has a couple of functions that would be something you would want to implement on your end. On update, on render, on GUI render. So on update is for updating physical properties of the object. On GUI render is for rendering the GUI, and on render UI, on render is for your graphics rendering. And these three functions are called in like on every frame. So for generating every frame, you go through all these three functions. Okay. All right. So the base class has a couple of things that you use to populate your scene, and yes. So it has a rendering context. The rendering context basically gives you access to the window manager and the renderer, which is currently being used for this particular app instance rather. Um, then you have list of models. Then you have a light container. The light container is nothing but a list of lights along with a couple more properties which you use to set the uniforms in the shader. And then you have cameras. Now, here I think I'll change the implementation of camera a bit, probably. Like instead of using vector of cameras, I should probably use a vector of pointers of camera, um, because uh, I mean, using camera class directly slices up the camera. So if I have like two different types of cameras, um, one way to differentiate them would be to have like a type member in the class, and the type would be some sort of an enum which kind of tells me if it's a perspective or an orthographic camera. But that would mean the user can set um the enum to something and pass in a projection matrix of something completely different. Okay. um, which would kind of break the application. So what I would want is, based on what the user is giving me as a projection matrix, I figure out what that camera type is, and then I populate that enum on my own. So yeah, moving ahead, these are for like internal purposes of the base scene. So as a user of the base scene class, you don't really have to worry about these things. That's why they are private, not protected. Yes, and so the functions that you would be using as a user are add camera, add model, and add light. These three functions are all you need to basically work with this, and then you basically have your custom overrides of on render, on update, and on GUI render. If you don't want to use those functions, you don't have to implement them, obviously. So for instance, we'll go through the scene of hello lights. So here, as you see, I start with mentioning that I'll be implementing this base scene, and I have one private member, which is the shader itself, and then I will be overriding on update, on render, and on GUI render. And here in the constructor, I use the initializer list to initialize my shader, and then I add a couple of models. So I have a few like pre-built models which are nothing but just a couple of vertices with some predefined properties, and they were more like they're more for debugging purposes, to be honest. But I just use them to create the scene anyway. So the floor and the walls and stuff. Yeah. So each model takes in a title and a couple other properties like, position, color, rotation, orientation, etc. Orientation, scale, etc. And the model class itself, uh, so plane, cube, etc., all of them are basically inheriting from the model class. But if you want to have like a model that you want to load, that does not really fall into, let's say, cube or plane, obviously, so you directly use the model class. The model class has many overloads of the constructor, actually. So you can directly give it a mesh if you want. You um, you can choose to give it a title, you can not choose to give it a title. It'll select a title on its own and those kind of things. One of those overloads is basically giving it a path to whatever model you want. um, just make sure that the textures are in the same folder as the model, because the code kind of assumes that they are, and hence uses the path to that folder for loading the textures. Yeah, and then you can add camera, and as you can see, camera definition, the second, or rather the fourth parameter is the projection matrix. And as of now, I don't think I have any means of telling which, because when I receive it, it's a matrix 4, like GLM mat 4 object. So there is no way of differentiating. So I have to figure that out. But let's see. Then you have lights. You have point lights, ambient light, you know. Again, like the overloads are, like I've written them in a way where you have a lot of flexibility. If you don't want to give it a title, it will set a title on its own. If you want to give it a title, well and good. And these titles are basically used in the drop downs. So make sure not to give two lights the same title, because then IMGUI has no idea what's going on. Yeah. Okay. And in update, you can do your animations. So currently I'm rotating the helmet and the table on which it sits. the update function, well, uh, it is um, it takes into account the time gap between two frames and tries to adjust the call accordingly so that a computer with a slow CPU, or rather CPU cycle, uh, does not end up calling this function on a slower rate as compared to a faster computer, which would end up calling this faster. So I have kind of accounted that into the code. um, but as you see, like when you shift the FPS slider kind of abruptly, it takes a bit of time to find that delta frame for a bit. So that's why it seems like all of a sudden it's speeding up, even though it is not. Okay. Um, oh yeah. So then you have on render, um, and in on render you bind your shader, you find your active camera, get your view and projection matrix, get your model matrix, give it to the shader. The shader does its calculation. The light container takes care of binding the lights. So I kind of make use of um, so for instance, this shader needs a bit of refactoring. Yeah, I need to extract these, a couple of them in their separate functions, but for now it's okay. um, Yeah, so I make use of these array syntax because I prefer using it like this. So um, um, so for example, the way you would be accessing this in the main function will be use spotlights, uh, square brackets 0 1 2, whatever it is. So the light container basically takes care of assigning the correct index, and assigning values to that index, so on. So that's a neat thing to have. Yeah, and then you go through individual models, load their materials. So basically I have a material class. There is a base material, and then there is again like an implementation on top of that, so an inheritance, so to speak. So I have named that, uh, find it, engine app. So it's here. So I have a base material, and then I have like the only one I have implemented is mesh basic material. Uh, this name I basically took from what 3JS people are using, so yeah, no points for creativity. Uh, and this is, I would say, a particularly interesting class. Uh, so I have tried my best to make sure there is least amount of copying going on between things. Okay, so for some crucial classes I have actually disabled the copy constructor completely. uh, so that would, as in like if I even try to copy this or accidentally end up copying something, the code would just not compile simply. So that's, I would say, a nice way of doing this. Like if you want to, like if you're paranoid like me about things being copied. um, and I have used smart pointers wherever possible, uh, unique pointers wherever I thought things would not be shared between things, between different classes, and smart pointers for wherever I thought things would be copied. Uh, Using pointers has specific advantages. Of course, if you want to use inheritance, uh, and rather like runtime polymorphism, um, then pointers is the way to go. Because if you use like non-pointer, or rather like, I don't know what's the word, raw reference of things, things get sliced, and they don't work the way you think they would actually. like unless you know at compile time what the object would be, and uh, like what type of object it would be, you would need to use pointer to kind of do a casting later on. Yeah, so that is one reason. And of course, if I'm dealing with pointers, I would rather use smart pointers instead of using raw pointers, because my god, they're terrible. uh but yes, going forward, so the mesh basic material has a couple of like solid color related properties, like albedo, which is basically the diffuse color, a base color, that's another name. The specular value, which is the reflection color. Opacity, I'm currently not using it in my models, but I plan on supporting some sort of an opacity map if there's something like that. Roughness, metalness, I'm not using roughness yet. I'm using metalness for basically the reflection. But then it also supports diffuse maps, and with an S, maps. So it's a vector of uh, textures. Why? Even I was confused for a bit, because I was reading this book, and they mentioned that like while giving example of the code, they had multiple diffuse maps, and I was confused for a bit, like why do you have multiple diffuse maps? That doesn't make sense. So I just kind of had a word with a couple of guys from the computer graphics community, and they seemed to be, I mean, what they told me was in advanced PBR, physics based rendering, sorry, physically based rendering, you would have more than one diffuse maps, and you kind of have an average over stuff, I guess. So kind of future proofing this, I uh, have a vector of diffuse maps and vector of every other map, as a matter of fact. And currently the way I have implemented the shader, so if there is any texture available for, let's say, diffuse property or diffuse component of the pixel, then the solid color part of that will be ignored. And like I mentioned earlier, I saw this yesterday in Blender. Apparently, you can tint the texture maps with these solid colors. So I think I might change the implementation. Yes. um, yeah. So the model property kind of holds. Okay. Before I go into that, so I kind of thought how 3JS implements it, and apparently you can share, like what they say is use one mesh but multiple materials, because meshes are more expensive. And I kind of rolled with that idea. So the way I have implemented the model, the mesh is completely decoupled from material, and the model itself holds that relation, which means I can reuse the mesh for a different model without worrying about what the material is. Uh, so here in the model, I have, sorry, here in the model, I have something called uh, the material pointer. So the material pointer holds the textures, sorry, the materials, and the materials and the index of this material pointers vector corresponds to the mesh list. So the 0th mesh will use the 0th material. Okay, and since materials are, like, it's a shared pointer of materials, so I can have two materials at two different indices, which are actually the same material, as in like they're pointers to the same material. So that way I conserve resource uh, by not copying materials, as a matter of fact. And then there is something called texture pointer cache, which is if two different materials are using the same texture, then this texture pointer cache basically holds a map. The key of the map is the path to the texture, and and basically gives the shared pointer to this texture, whatever it's holding. So yes, I would say like it might be premature optimization, but I would say I had nothing better to do because yeah, I mean that's all I was doing for Christmas, so why not? But yes, of course, there are tons of details and things I would love to talk about, but probably in a different video. And as for like in which direction I might take this into, see, the thing is, I don't expect Dynalar to be a full-fledged rendering engine ever. It's not going to be that. The intention of this project was more for a sandbox and for my own practice because uh, I kind of needed a refresher on C++, and this really helped me a lot, like jogged my memory, really. So now I think the direction in which I would be going is PBR, more advanced lighting, and PBR, of course, um, and post processing. So bloom is an effect I want to implement in this. Uh, Other than that, I think. Uh, What else? Oh yes, a scene graph. Scene graph I think should be easy to implement, uh, but let's see. Yeah, I think that's all from me. If I end up having more updates, then yeah, stay tuned. And thank you for watching. Have a nice day.